My name is Bonaventure Dusu, and today I'm very pleased on my behalf and on behalf of other cultures to be presenting your work titled AfroLM, a self-active learning based multilingual pretrained language models for 23 African languages. So we are going to start by a quick overview of the current state of multilingual pretrained language models on African languages. But it's important for me to first of all emphasize or like remind that current groundbreaking breakthrough in AI, NLP are made possible with the use of large-scale multilingual pre-trained language models. So if it's the case, why do we have only currently three, including AfroLM, only three Africa-centric multilingual pre-trained language models? Even if we look at the number of language covered, which in which AfroLM is topping with 23. 23 is still very insignificant compared to the 2,000 plus languages that the whole continent, African continent, has. So there are many models, multi-language, large-scale models out there, but why there's some very so little, three is very insignificant compared to how many models are created every day. Why are there so little compared to African languages? The key thing here is the lack of data. The lack of data, or one of the main reasons here is the lack of data. And that lack of data is a problem because those multilingual pre-trained language models rely on huge amount, massive amount of data to be able to give or to achieve high performance, which is something we cannot afford in the context of African languages. This is why today I'm going to be talking to you about uh, active learning, which is a very interesting concept. And I'll walk you throughout our work in this presentation. So what is active learning? Active learning is technically a semi-supervised learning algorithm whose idea is to incrementally, consistently, consistency is key because whatever the metric we define, we want the performance to be increasing, to be consistent. We don't want shocks like jumping down, we don't want that. And dynamically labeling label data during the training phase with the hope or with the goal that our model that we are trying to build, the model whose parameter we are trying to optimize, will be able to identify samples that are going to be mostly beneficial for him or for it. Yeah, it's not a person for it to learn from. Here, the query can be a person, can be a model, like for instance, a classifier, can be anything. Now, why is active learning interesting? It's interesting because even though there are very few NLP-wise application or like research about active learning, the existing one have been able to show that with only 20% of labeled data, we can achieve as much as 98 to 99 of accuracy, while other approach actually need at least 50% of the amount of labeled data. And this is very crucial, as I was saying, because African resources are very scarce. Some of them are not even discoverable on the internet. The other thing is high performance. While we are still having very decent amount of data, we can also achieve as high as possible, according to the metric that we define in the least number of active learning training round, which is also very important because we don't want to be training forever. So our framework is technically suppressing or deleting, removing the need of the query and of the annotation by human experts, for instance. So the query, as I was saying, will be a real world model, a person, or a model classifier. But in this context, because there are some languages that we're covering that are not covered by existing pre-trained language models, even the African-centric one, we use the model itself to be able to perform those two stages. So the model is trained at the current active learning run and to be able to query itself and generate new features that are going to be used for the next active learning round. So this is technically what our framework looks like. We have a data set that we split into two sub data set. The first one is the training, which is made of like a given percentage, for instance, of the initial data set. And the remain is like the headout, like a kind of validation. Then the training data set is used to train the model. and the header data set is used to prompt the language model that has been trained at the current active learning round. So it's like we take sentences, we mask a part of the sentence, we use the remainder as prompt, and through iterativeness to token prediction, we are able to generate new sequences for each language that are then appended to initial data set, and we restart the whole process. You can find more details about this like in the algorithm one for of our paper. So we tried this. We tested our model on like various experiments, name entity recognition, the master kernel, both data set, the first one, and the second version, which has been recently accepted at EMNLP. We also tried on text classification, and to see how much our model generalized across domain, we also perform out of domain experiment, like by performing sentiment analysis experiment. Yes, because our model was trained only on news data, on news domain data. As we can see here, AfroLM is outperforming all models, existing one at free beta, is outperforming MBERT and XLMR, even though those large, huge models have been trained on 100 plus languages and on more than 2.5 terabytes of data set. AfriBeta is still like okay, but still AfroLM was pre-trained on less data, but still was able to outperform it. It is the same thing on, we noticed the same thing on the master kernel 2 data set. And in average, we also have the same phenomena on the text classification experiment. Now, on the sentiment analysis, it is also crucial and very important that we can see that AfroLM in our active learning framework is able to generalize better compared to other models. So the first setup is, for instance, we fine-tuned and evaluated the model on the movies domain, and the other one is we fine-tuned on the Twitter domain and evaluated the movies domain. And the result shows that AfroLM is able to generalize better across various domains, which is very important. In conclusion, we propose an active self-active learning framework, which is very data efficient, but yet are still high performing and very concurrency with model a higher, huge, large scale, train on terabytes of data models out there. AfroLM, the model that we pre-train in that framework, is able to achieve state-of-the-art against AfriBeta, MBERT, SLMR on NER, text classification, and sentiment analysis tasks on African languages. And of course, it generalized better across different domains. As future work, we want to expand to more languages, obviously, and we also want to include some weighted laws because currently, if you imagine, Swahili has, for instance, 1 million of sentences and Fon has, for instance, 5,000. The loss from Swahili, because the loss of the data set is technically the average of individual loss per data, of the overall data set is the loss on each individual language. The loss of Swahili might be high and the loss of Fon might be low, but then the average will be high. So providing this weight, we be able to give or like provide equal or like not equal, but the necessary and the right attribution of each language to the contribution of the overall let me say loss of the overall data set. And we also want to include more diversity because technically what is currently being done is throughout the process of next token iteration, we are just using the top one, the best token predicted. But it does not guarantee that we will always have different token. We might fall in this situation where we have sentences that are more alike the initial sentence. That's why diversity is important. So, and that's why we propose a formula to be able to do this. So technically, d of x and xi and x prime I will be the word error rate. We use the word error rate, or we are planning to use the word error rate, which in context of ASR, for instance, would be the lower the better. But here we want it to be large. That, or we can also use the blue score to compute the blue score between the generated sentence and the initial sentence to see how different they are. We can do either of those. So the T here is a threshold. How much are we, I mean, how much are we allowing the sentences to be different, at least different from each other? If it's too high, we are technically going to have an empty data set. If it's too low, we are going to have more or less the same sample. So the data set will keep his side, or we just have redundancies. So that being said, thank you for your attention. I'm looking forward to your questions. This is the QR code to scan and to like go to our GitHub. The data set, the code, everything is already open source. You can also use the model directly from Hugging Face. And yeah, I hope you enjoyed the presentation. And if you have any questions, feel free.